test. Right. Can you hear me? Anna? How are you? Viewers. Check. Thing. Okay. Uh, can start. Rangamune. What is it? Right. Hurry. Well, right. Okay. Right. Online students now may. Where is the camera? Make give this. Hi. How's life? I normally ask that before starting class. How's life? Said. And girls on that corner. Can you see me? If you want to see me through this, then come on. If you want to see me live, just come here or do whatever. I don't. Meantime, you can't see the online meeting. I'll look into it in a minute. But online students, you can send your messages, the YouTube live chat or the Zoom chat. The moderator will reply to those. Sorry. If there is some interesting messages, I'll look into that. Otherwise, they will reply. Any question, chemistry regarding or anything, ask. Sorry. Okay. Start. Anyone who is new today? Ah, right. Shall we the tooths? Anyone who is new who doesn't have the tooth, can you please raise your hand? Raise it properly. The no, we'll come to you. We'll come to you. It seems like most of you are new. We just may fine. Yep. And anyone who didn't get the weekly paper? Aufbau, all of you got the weekly paper. Aufbau 1. Since you are new, some of you might not have answered it. You didn't get. Weekly papers සම්බෙච්ච නැති අයටත් ඒ ටික දෙන්න. ඒක නම් I think only a little bit of just raise if you didn't get the weekly paper අන්න එතන කෙනෙක් ඉන්නවා. There are a few here. I'll explain how it happens, and from next week onwards it's sailing, but I'll explain how everything goes. මේකේ මේ there wave. I think my movements are sort of wavy. නේද? පොඩ්ඩක් නැද්ද? ගතියක් එක්කනේ එන්නේ. Effect එකක් තියෙනවා. I don't think it's very fancy, so try to change. I don't know whether it's possible. Something about. Hari, okay. Hari, then we'll start today's work. Oh, anyway, this is how our day goes. First, once you enter the class, when does the class start? When does the class start? At 3. So try to be at 3, right? I mean, if you are late, it's fine. Maybe you have some extracurricular work, maybe transportation issues, you might have delays, it's okay. But always try to be at 3 here. And then once you are entering, we'll keep the weekly papers here, right? We'll keep the weekly papers here and make sure to get one and answer it. Normally, it will take 10 minutes in the beginning. Later, it will be around minutes. Once the content increases, for calculations, normally we spend about 30 minutes for a weekly paper. And the weekly paper will be discussed, right? So, come at 3. Check whether make a pen or the online. Come at 3. from 3 to around 3:20, you will be answering the weekly paper. So don't be late. Don't make it a practice to join at 3:20. Sorry, some students do that. Sorry, some students do that. They join at 3:20 thinking, okay, it's fine because anyway, sir is coming at 3:20. No, that's not how it is done. Weekly paper is very important. Anyone who has read Atomic Habits? Anyone who has read the book Atomic Habits? Have you heard of? No, it's not a chemistry book. No, Atomic, no. Not a chemistry book. Anyone? Have you heard of the book Atomic Habits? Yes. Have you heard of Rich Dad, Poor Dad? Some. No. I only know my dad. Or else some might know if you are bad, I am your dad. So there's a set of books which you should read after A levels. One is Atomic Habits. In Atomic Habits, we learn how important is a very small step which is done repetitively. Right? Which is done repetitively. In Atomic Habits, we learn about a concept which is called 1%. What is the answer of this? What is the answer of this? 1 to the power of 365? 1. But if you improve 1% every day, what is the answer of this? 1%. Actual value is 1, you 0.1. I mean, you understand that anyway. What is the value here? Any ideas? Yeah, around, I don't know the idea anywhere. 1.01 into is a very small increment here, but 1% every day. It's around 37. Which means if you improve 1% every day compared to the previous day, you will improve 37 times. That's the point of the weekly paper. Now the weekly paper we give you is very easy, very basic things in the beginning, but that is going to be a very important part of the class. Right? So always be on time and answer the paper. It's very, we can answer that later. I'll do those later. No, don't do that. Just come and do it. I know the questions can't be difficult in the beginning, and that's fine. Answer whatever the questions they have given, and that's it. Mainly we'll ask questions from the previous day or previous days. Previous couple of days, we'll ask questions. That's how it goes. Right. You can look at the tunes later. When I'm talking, don't pay attention anywhere else. Sorry. That's what we do first. And then I normally start the paper discussion, and we'll normally discuss it in another 10 minutes. Normally for the first days, time can have a small delay because joining and all. But anyway, we'll try to finish everything around 3:30. Now, since we are starting a little late, 3:45, around 3:45, weekly paper will also be discussed. Then starts the theory class, and theory class will go from 3:45 to 6:30. After unit 1, it will become 7. I know all of you are very like it, right? All of that to learn. So it will become 7. And there were so many issues sent by you to our hotlines and WhatsApp numbers. I'll talk about those after the interview. Okay, I'll talk about, especially there were issues with science students. Anyway, had issues. Address those later. Hurry. Now, if you haven't completed the week paper, just go through it and see. You know, now, did anyone who didn't know that you had missed day 1? Or were you aware that you knew? Most of you knew, right? This is day 2. This is not day 1. So always the day 1 recording was sent to it won't be sent to the WhatsApp group all the time, but it will be there. Day 1 recording, previous recordings can be taken. Regarding recordings, anyone who has watched recordings in O levels? Have you watched? Okay. I don't know whether you know about recording. Miss a session, the recording is available. But don't make it a habit to miss the session and watch the recording. It's a very bad habit. It will never continue, right? Not like watching a film. Not that interesting. So won't watch it. Then what happens? I'm talking because it might be too late once you understand this. Once you are unable to watch the recording, then all of a sudden you remember, I couldn't watch the recording. Then what happens on the next day? Don't come to the live class on the day 2, day 1. Don't come on day 2 thinking I'll watch the recording of day 1 on day 2. Here we go. Then what happens? We'll watch half of the recording. We'll never watch 3 hours. the given time slot, and then you have half of that recording and this as well. So it's starts to pile up and will very quickly become a disaster. So make sure that won't happen. Very important, right? So never go for the options recording. That's why even though we provide it, even on the group, I didn't mention about any details regarding the recordings because I don't want to promote watching recording. Sorry. So always make sure to join live, but definitely there can be issues. You might be doing curricular work, you might have emergencies, you might have transportation issues. If you are not joining on that day, make sure to have a specific time slot to watch recording. Never skip watching the recordings because very, very quickly escalate and you trouble. Sorry. Yeah. So regarding the students who joined today, you can watch the day one recording later, tomorrow or today if you have time. You haven't missed a lot. We did theory for about 1 hour last week. We first introduced the class and then we checked what you can remember from O levels. And then on the last hour only we started the so you haven't missed a lot. We'll continue from what we have to continue, but you can watch it. Sorry, most of you might have watched it. Then and tutor. Is it? Yeah. Thank you. Shall we take it up? Right. Be late, okay? Okay, then we'll start discussing this Aufbau 1. Now, when I'm teaching, I want complete attention. I don't want you talking with your friends, and I'm very friendly. That doesn't mean I can't control you, right? That's not what it means. Don't try to miss. I always want to be friendly with you because A level won't be a very, very easy journey. So I want you to be as a friend. That doesn't mean you shouldn't respect me, right? I'm not very older than you, but we need to completely understand our roles. I am the teacher, you are the students. Always make sure to maintain discipline, then it will be very easy for you. Then it's easy, right? Okay, we'll discuss. Now listen, now pay attention. Aufbau 1. Aufbau is the German name for building up. You will learn about the Aufbau principle later in few weeks. We'll get a weekly paper every week from theory you did from the until A levels. Roughly you will get about 120, 130 papers. Right? Take 10 minutes and answer the question from last week. Right? Will be discussed today. Okay. First one, what is the difference between a compound and a molecule? Now we didn't write that, but we discussed it from O levels. Maybe weekly paper. Anyone who doesn't have this? Sorry? Yeah. There are a few. Raise your hand and get it. Hurry, okay. What is the difference between a compound and a molecule? What is the difference between a compound and a molecule? If you haven't got the weekly paper, still pay attention. You will get it now. Hurry. Compound, molecule. Last week we discussed this, and some had issues and some came and asked me as well. What is a compound? What is a, first of all, what is a molecule? What is a molecule? Or else to make things easy, now I want answers. Make things easier, what is the difference between a compound and a molecule? Any ideas? What is it? Tell me a molecule which is not a compound. Tell me a molecule not a compound. Anyone? A molecule which is not a compound. Hydrogen is the molecule which is not a compound. Does everyone agree on that? I don't want any other answers. Do you agree on this? That is saying hydrogen is a molecule but not a compound. Anyone who disagrees? Don't be afraid, Harid. When I ask a question, answer, it's fine. No one is here to laugh. No one knows chemistry. Even I know a very little chemistry, right? Compared to the entire chemistry, we know a very little. Always be humble enough to learn. It's fine. So just answer. It's okay. Online again, online again, yeah. Does everyone agree? Molecule compound? Yes, this is a molecule which is not a compound. Then the other way, any example for a compound which is not a molecule? Any example for a compound which is not a molecule? Yeah, just chance, it's fine. And here, if you have anything to say, if you are too shy, you can send a cheat. But always send appropriate cheats because the cheat can be sent back. I can find who sent it. Don't send inappropriate cheats. There were a few last year. Methane is a compound which is not a molecule. Agree? Do you agree? Why? Why do you agree? The compound which is not a molecule. Methane is not a molecule. No, these were taught in all levels. Skill and you don't act, Ari. I know you know. Don't act and let me just say. I know you have worked well. Most of you have done well in science. You should know the answer. The thing is, if any kind of a bond is formed between two or more atoms, then that is known as a molecule. If any kind of a bond, maybe ionic bonds, covalent bonds, whatever, right? Those are known as molecules. But if the atoms are different, then that can be known as a compound. So the basic difference is what? The atoms should be different, otherwise you can't call it a compound. So here, become a compound, it should be between different atoms. Different atoms. And here, it just requires a bond, sort of a bond. Then can we have such an example? Can we have such an example? No, we can't. Why? All the compounds are with molecules. So if I draw a Venn diagram like this, the Venn diagram, this contains all the substances which have chemical bonds, maybe ionic bonds, covalent bonds, whatever. Then this is known as molecule, set of molecules. But then if I circle out the set of molecules which have different atoms, then we call those compounds. How it normally works. This is the most used, the most frequently used definition. Is that clear? That clear? That is what. Right. So how to write the difference? Now that is not in unit 1, it is something from all levels. How to write the difference? The difference is, now they are asking the difference between a compound and a molecule. We will write something like this. Any substance with a chemical bond. We can learn better definitions later, just all-level definition. Any substance with a chemical bond known as a molecule. Any substance with a chemical bond known as a molecule. While and under molecule, we haven't written containing 2 or more atoms. If you want, you can write, but it is almost given. Why? Because if you have a chemical bond, obviously you should have more atoms than 1. If you want, you can mention that as well. But while name it a compound, name it a compound, name it a compound, name it a compound, there should be at least different atoms. There should be at least 2 different atoms a chemical bond. While to name a compound, there should be at least different atoms, the chemical, right? Okay. So what's the simple difference? The atom should be different for a compound. For a molecule, it's not. Even having the same atom. Okay, so this is the easiest way to represent it. So you can say all the compounds are molecules, but all the molecules are not compounds. Whether those are okay with you, whether you are comfortable with those, right? What you can draw this and show what that means. When you are writing an answer in your term, there's no need to draw these things. This is better for you understand, right? So we can't find the situation. We can't give an example for a thing which isn't a compound, which is a compound, which is not a molecule. That doesn't work here. Ne? That is the idea, right? What you can mention that. What does this mean? All the compounds are molecules, but all the molecules are not compounds. You can mention that if you want. That is from O levels. Right? If you have any question, anything you can't understand, online students, you can send it through the chat or the YouTube live. And from next week onwards, for online students, we won't have a YouTube live. It will be for physical students. If you have questions, once I'll go around the class, you can ask, or you are confident, you can raise your hand and ask up to you. Or else you can send a cheat. Whatever the thing, or after the class, you can come and ask. Right? Right? Right. There's a second one. So all of you have the weekly paper? If you have, write 2 postulations of John Dalton and explain why those were wrong. How many postulations did John Dalton come up with? How many? 4. Can all of you remember the 4? Remember. What were the 4? What was the first one? He said, we'll just briefly go. He said the first one was, he said everything was made out of tiny indivisible particles called atoms. And why is it wrong? He said everything is made out of atoms. It is indivisible. Why is it wrong? One word answer. Subatomic particles. You can explain it, but that's what you should remember. Subatomic particles. Now, if someone wasn't there for day 1, you can just ignore and watch it later. Then what's the second one? He said all the atoms of the same element is identical. Example, he said if you take carbon, if you take the element carbon, all the atoms of carbon should be identical in what? Mass and size. Okay, why is it wrong? Because of isotopes. And similarly, he said the opposite as well. Similarly, if you take 2 different elements, what happens? Take 2 different elements, it should be different from mass and size. Again, we learned why it is wrong. So, what is the third one? He said, I can't remember, I don't know. What is the third one? Now you should say, I can't remember. I need the answers. I don't know. I honestly don't know. What is the third one? Yeah, he said, atoms of one element can't be converted to another. Why is it wrong? One word, nuclear reaction. So you can convert a carbon to a nitrogen. Right? Okay, that's 3. What's the fourth one? Compounds are made out of 2 or more atoms in simple numerical ratios. Right? Now, when you are writing an answer, always don't try to remember everything. Remember the keywords. Then you can write it in your own words. That's fine. That's how I give the note. Before the class, when I get ready, I can't remember the entire thing. I remember the keywords and the key ideas. Then I convert it to my own words. That's why you would realize when I'm giving the note, if I give the note twice, it won't be identical. The idea is the same, but the way I give it is different. That makes sense. Always try to study like that, right? The fourth one is simple numerical ratios. In simple terms, what does that mean? If the compound is carbon dioxide, what is the ratio? 1 to 2. 1 carbon atom, 2 oxygens. If it is H2O, 1. If it is, let's say there are compounds like P4, O10, 4 to 10. Still this is new, simple, right? Simple means not the value is small. It means the value is a whole number. The value is a whole number, right? Purna sankhya. Then it's 4 to 10. Still it's 5. Why is this wrong? Because you have compounds like this. Later the compounds were discovered like this. Fe 0.95 to O. Right? That's why it is wrong. There now, that's why it is wrong. We have all 4 and we know briefly why all 4 are wrong. Now, if you remembered, if you were there, you should have written and write why those are right. Now, don't be afraid to write answers. No need to worry whether your answers are right or wrong. If you want in the class, you can show me and ask, but be confident about it. No need to really worry about it now. Then the third one. Complete anything if you want. Then we'll go for the third one. What is the atomic model John Dalton proposed? Explain the model in 1 words. What is the name of the model? Golf ball model. What does that mean? What does golf ball model mean? That the atom is a tiny how to read this? That particle. Right? Which doesn't contain anything inside. That's it. So simply by looking at the golf ball model, you should understand that the atom is small, shape of the atom is this, and it doesn't contain anything inside. Those are the 3 main things you should look and understand. It is small, shape, and it doesn't contain anything inside. That's how Dalton thought about it. Right? So, first 3 are done. Others can complete those later and we'll can ask all. And physical students or online students, if when you are asking questions, the language is not an issue. I mean, I don't Tamil, but you can ask in Sinhala, right? Fine. I am maintaining English here because that's how English medium classes should be done. Last week also we talked about this. Never learn English medium chemistry in Sinhala. Sorry. It might be easier for you because, of course, for most of you, the native language is Sinhala. Even for me, of course, it might be easier at first. But you will later find the consequences. It won't be easier writing answers. For O-levels, it might not matter. But for a subject like A-levels, for an exam like A-levels, matters. If you are not sure, you can test that and say it. Okay. Done? Sorry, completed. Okay, then we'll continue. Come to the tute. Get the tute. Online students may come in. I would not soft copy. Online students, your tutes will be delivered by next week, right? Then you will get 2 tutes delivered. Physical students, you will get another tute next week as well. Online students, for the moment, you can use the soft copy on the group. If someone has difficulties finding it, just text. So we'll inform you. I want you to complete the first and second pages. I'll give you 10 minutes max. Complete the first and second pages. You don't have the tute. Now there are students without the tute. Eh? Please raise your hands without the tute. Then we'll come to you. There's one here. Others quickly. Eh? Then go. What? Who asked for 2? You know, you can hunger. Right. Do the first page and the second page. Page 1, page 2. Complete. I'll give you 10 minutes for this. Meantime, questions you can ask. Yeah. Don't talk, don't ask from your friend, answer. Don't start chit-chatting, it will continue. There might be some things you might not know. If someone completed page 1 and 2, you can do the others. ප්‍රශ්නේද? Some had found answers. I told there weren't any. Ne? Think. I wanted to come to that, but so I ask the question. We'll talk about it later. Read page 1 and 2. Done. If you have done page number 1 and 2 regarding the weekly paper, there were two very good questions asked. One, if you have done, you can listen to this and later think of answers. Sorry. One, what are heteroatomic molecules? What are heteroatomic molecules? One. Two. What was the second one? No. H2 is a molecule, right? Now things start to get confusing. That's worry. Then is H a molecule or a compound? What's HD? Deuterium. Hydrogen, but the different isotope. Think of those while answering. If you have completed, you can answer. So done. I think you haven't learned the founders of subatomic particles. Founders of subatomic particles. No. Okay, you can keep that. Everything else has been learned. You have learned everything else. Give you 2 more minutes. Complete page 1 and 2. Done. Correct. Shall we discuss? We'll quickly discuss. Then I'll come to this later. After discussing, I'll explain how. Now, since you're asking good questions, I'll have to explain everything perfectly. So I'll explain why this might be a little bit contradicting what you have asked, and then we can solve this as well. Sorry. Before that, first discuss the ideas from O levels. Okay. Again. What is matter? What is matter? What is matter? Things you need to fulfill matter. One, yeah, you have to occupy space, so you have to have a volume. Then you have to have a mass. Any substance with a mass which occupies space, known as matter. Any substance with a mass which occupies space is known as matter. The letters are too small. Tell me, Hari. Can you see? Fine. Okay. Not let us know, then I won't do anything. Occupies space. That's one. Then to the second one. What is the building block, basic unit of matter? The atoms. Normally, you can consider that as atoms. Third one. What are the three main subatomic particles? You know those basic stuff: electrons, protons, neutrons. And do you know about the charges of those? Any ideas? Electron, proton, neutron. Okay. Then, what are the charges of? What is the charge of electron? Negative. That's it. You don't know anything else. Negative how much? -1. In what unit? How do we measure charge? Okay, others, how do we measure charge? Can't hear. Others, how do we measure charge? Danne? How do we measure charge? My dear. To measure charge in coulombs. Why is the C capital? Because it's a name. What are the other units with capital letters like that? Newton. Okay. One one we use very oftenly. Kelvin. Right? Kelvin, watt, maybe newtons. Why is it capital? Because it's a name of a scientist, right? Otherwise, always the unit is simple. Now, did you learn the 7 main units? What do you call that? You learn 7 units physics, right? Did you? No, not yet. Fundamental units of measurements or something like that. Do you learn? What are the 7? Can you remember the 7? Meters. Meters, sorry. I'm asking for the units. Okay, kilograms, seconds, amperes. What do we measure by amperes? Current. Then Kelvin. Yeah, 1, 2, 3, 4, 5. What else? Candela. Okay, it's simple CD, ne? Can't remember. What do we measure by candela? Light intensity. What does that mean? Light intensity. How sarada wage ekadda? Don't know. Luminous intensity. Yeah, okay. I don't know. Maybe. I don't know. Candela. We never use it. Then volts. Moles. What do we measure by moles? Amount. You measure amount, right? Now. We have 7. So coulombs is not one of those. We use coulomb to measure the charge and its capital. So you can measure the charge of electron in coulombs. Later you will learn the charge is actually this. 1.6 into 10 to the power minus 19 coulombs. Is it a very large value? Large or small? Then the proton is positive, the same value. No need to write, just going through what we are supposed to learn. What's the charge of the neutron? What's the charge of the neutron? 0, it's neutral. Okay, so you have the 3 subatomic particles. Now you can write the fourth one, subatomic particles. No need to write the founder, we'll learn those later. Under charge, if you want, you can just write minus, plus and 0. If someone wants, you can write the values as well. We'll later learn those. Complete that. Sorry. Then name the scientists who discovered the following. The planetary model of the atom. Who? Ernest Rutherford. That electrons travel in definite orbits around the nucleus. Now, why do you say? Now, I took a class in Kurunagala as well. All said that. Why? Did Niels Bohr say that electrons travel in definite orbits around the nucleus? We don't know whether Niels said, but that's what our teacher said. That Niels Bohr said. Did Niels Bohr? Yeah. J.J. Thomson. Really? Now, what did Ernest Rutherford say? Now, what's Ernest Rutherford's planetary model? What does it say? That the electrons orbit around what? Positively charged nucleus in what happens in the planetary system? You have the sun. Around the sun, all the planets orbits. In which paths? Fixed paths, right? Isn't that the planetary model? I don't know, I'm asking, I don't know. Always assume I don't know chemistry. Then it's easier for you. But come to the class next week. Again. What does the planetary model say? Isn't it the explanation of the planetary model? I'm asking. Or else, what is planetary model? Then what did Niels Bohr say? I don't know up to what extent you have learned this in O levels. Niels Bohr said that it is wrong. He said it's wrong. Sorry. What Rutherford said was, now what happens in the planetary system? You have the sun. Around the sun, all the planets will orbit in a fixed path. The fixed orbit. Right? That's what Ernest Rutherford said. So he symbolized the sun as the positively charged nucleus, and then the electrons were the planets. So what he said was, electrons are traveling in fixed paths or fixed orbits around the positively charged nucleus. That's what they have given in the second one. That's again Ernest Rutherford. Then what did Niels Bohr do? Now, if someone remember this, if you didn't do O levels, come on, you'll learn this later. Hurry, just most of you can remember, I can see. What did Niels Bohr say? He said it is wrong, that it is possible, and he proved why it is impossible, and then he proposed a better version of it, saying it is possible. Right? So he actually said that this is wrong. We'll learn that. Anyway, the answer for both should be Ernest Rutherford, not right. Someone disagrees, you can say, fine. There are things in chemistry that I don't know. So if you ask a question which I don't know, or if I am not sure, I'll be honest and I'll say, man danne, right? I'll always say that. And I'll check and confirm. That's it. You can question me. It's perfectly fine. Okay. Then 1.2. Right? Okay. 1.2 says, indicate the maximum number of electrons that can exist in an energy level in the table below. The table below. So the table has energy level 1, 3 and 4. On the other side, number of electrons. Okay. What are the number of electrons? Can you remember from O levels? 2, 8, 18, 30. Relationship. Can you see a common term? Do you know what a common term is? What's the common term for even numbers? 2n. What's the common term for odd numbers? 2n minus 1. What does the common term mean? What is the meaning of that? So if you have 2n minus 1 for the common term, if I ask for the 10th odd number, put 10 here, then it will give you a value. That is the 10th odd number, right? That's the idea of the common term. Have all of you learned that in all of us? Now what's the common term here? 2n plus 2. It doesn't work here. 2n plus 2. 4 here, then 4 times 2 is 8, plus 2 is 10. So it should work for everyone, every term. Can someone, if you get the answer, don't shout. I want all of you to try. Of course, it's not chemistry, but it is A levels. Can someone come up with a common term? There is a common term. Try to figure that. You can do it somewhere else, not in your notebook. Try to find the common term for this. Now in O levels you learn this, but in A level chemistry we write as a theory point, this is the common term. No, planetary model was proposed by Ernest Rutherford. You will have those confusions because in O levels they don't teach it exactly. So when something is proposed, it's not very direct. Because they don't start today I am going to propose the planetary model. They do a lot of experiments and accidentally they propose things. Then credit should be divided. That's why there are confusions, but if someone asks who proposed planetary model, it's Ernest Rutherford. About heteroatomic, I'll explain. Right? And students, all of your questions will be answered either by me or ask anything. Hari? Yeah. Count. Anyone? Don't tell us. Others? One student has found the answer. Count. I can't ask. Just try. Find a comment. Try something. When I ask you to do a calculation, just don't stare at your book. Try to do something. Count. What is it? 8. Fine. Count. Someone is finding it difficult to get the answer. Try to get the common term for this. Be very easy. What is the common term here? What is the common term? Yeah, it is n squared, And now what is the common term here? So it is n squared, right? The square is here, square of 2, square of 3, square of 4. So what is the relationship between this and this? All the numbers have been doubled. 1 into 2, 4 into 2, 9 into 2, and 16 into 2, isn't it? Then what should be the common term here? n squared. So the common term is, if the energy level is n, then it is 2n, not n squared, it's n squared, right? So put n and you can substitute and see whether you get the values. Common term is 2n squared, right? And moving on, how do the energy levels and the energy gap between them change as you move from the nucleus? Any ideas? I think that's not in O levels, What did you write? Did you write? You have no idea. Okay, forget about that. We will discuss that. The third one. What is the third one? What is electron configuration? Simply the arrangement of electrons of an atom or ion. That's it. Arrangement of electrons of an ion or atom. For A levels, they won't ask questions like this. Okay, what is this? What is this? Name 5. එහෙම පරිසරය වගේ වහන්නේ නැහැ. They will check whether you know the concepts. Till you haven't learned any of those, questions look like this. Right. 1.3. Define atomic number. තරහ ගන්න එපා. Define atomic number. What is atomic number? What is atomic number? The number of protons, right? Number of protons in an atom or in a molecule, atom or ion, no. Number of protons in an atom or molecule. No, sorry, atom or ion, molecule. Number of protons in an atom, ion. සල්ලි වැඩි වගේද? Since I heard a noise, I just wanted you to know you are eating something inside the class. I am not going to say do it or do not. You won't, of course, obey my words. You will try to without me finding it. Ne? If you are eating a chewing gum or a toffee or something, when you are removing the wrap, do it at once. Then I look at, I can't find anyone. Then again, so do it at once. Well, tip. Define mass number. Define mass number. The sum of protons and neutrons again in an atom or ion. Sum of protons or neutrons in an atom or ion. What? For the third one, we don't need the what part. It's just an atom of sodium has atomic number of 11 and mass number of 23. All of you wrote the answers, right? First one, number of protons in an atom or ion. Second one, number of sum of protons and neutrons in an atom or ion. So sodium has an atomic number of 11 and mass number of 23. They are asking to write the number of protons and electrons. That's very big stuff. Do you know this notation? You have written this, right? The standard notation to write the atomic number and the mass number. So this means the atomic number. Again, you will learn all of these from the beginning. This is the atomic number. Then this is the mass number. Right? Atomic number, mass number. See? And so what are they asking for? The number of protons. What is the number of protons here? What is the number of protons for sodium? Simply the atomic number. So it's 11. The number of protons is 11. Then the number of neutrons is 12. Why? Because this is the sum of protons and neutrons. So if the proton is 11, neutron is 12. Then what is the number of electrons? What is the number of, again 11. How do you know that? Because for an atom, the number of electrons and protons are the same, right? So if I give something like this, let's say, I'll write it here. Tell me the number of protons and just write, take 10 seconds and write somewhere the number of protons, neutrons and electrons. For N7, 14, 3 minus. right? But you have, you don't need this. Yeah. What is it? The number of protons, how much? 7. Number of electrons will be 10 then, 3 minus. Number of neutrons is again 7 because this is 7 plus 7. Now to write this, what if they give it like this? It's still possible to answer, or is it not? If they give it like this, let's say something like this, can you still give me the number of protons, neutrons and electrons? Okay? Can you still give me the number of protons, neutrons and electrons if you give it like this? No. Yes. How? How do you know the number of protons here? You know its place in the periodic table. Where is oxygen? 8th. Ne? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. The 8th element. Is it fixed? Yes. So can we say without any issue that the 8th element will always be oxygen and it will always have 8 protons? You can. So this is not compulsory. Maybe in your textbooks in O-level, you have seen carbon 12 like this. It is not compulsory to write 6 because it is obvious. But you have to write this. Why? Because it is not. You have carbon 13, you have carbon 14. Even in normal, when we are talking about this, we won't say carbon 6, 12. When you say carbon, 6 is given. You only say whether it's carbon 12, carbon 13, or carbon 14. Does that make sense? No. Right. So here it is 8. No need to give it. Then this is 8. Then 18 minus 8 will give you the number of neutrons, which is 10. 8 plus 2 will give you the number of electrons. That's obvious. Sorry. When I'm teaching, I'll maintain a certain level, a certain bar, which is a very low bar. Anyway, I'll maintain. So if some of you don't understand the point which I just say, that means I assumed it was obvious. But come and ask. Sorry. Don't be afraid to ask. Even after the first day, some parents called me and asked chemistry questions. No, you can come and ask. One of A-level students, right? Make sure to come and ask. Don't be worried. Don't be afraid. Okay. You have that. Then you can complete the table. The table, you can do that. Then the 5th one. Come to the 5th one. Finish everything. If you want, you can write this somewhere and then come to the 5th one. First one again. But no, the 5th question, the 5th sub. Why is atomic number used to identify an element instead of the mass number? Why? The same concept I explained here. When you say the atomic number is 6, we know the element is carbon. But when I say the mass number is 12, do we know the element? No. It can be beryllium, it can be carbon. We don't know. So your answer should be, so the idea is, later you will realize, instead of saying carbon, we say the element with the atomic number of, right? That's what they're asking. But we will never say element with the mass number of 12 for carbon because it depends from, first of all, there are other carbons with different mass numbers and then there can be elements which have a mass number of 12, right? So it is different. So your answer should be atomic number is a constant value. If you have written something close, it's fine. Atomic number is a constant value for an element. What was it? Atomic number is a constant for a given element, while mass number is not. Mass number is not. Something like that. Enough. Then you can do the 6th one, it's easy. 7th? What's the 7th one? For the sixth one, you can just write this. Aluminium with 13 protons and 14 neutrons means what is the mass number? 27. So you can know those. Not 13 and 14, it's 13 and 13 plus 14. Make it. What are isotopes? What are isotopes? Substances that have same atomic number with different mass numbers. Straightforward. Substances that have same atomic number with different mass number. Sure. Okay. That's the seventh. What are the isotopes of hydrogen? Draw the standard notation, symbolic representation of them. How many isotopes does hydrogen have? 3. What are those 3? Rhodium, deuterium, and tritium. Okay, so do you know the symbols of those? I think last week, without knowing that you had learned the symbols, you haven't learned the symbols, I told those. For O levels, did you learn protium, deuterium, and tritium like this? But normally in A levels, you can use this. For protium, you can go with this. Deuterium, we use the D. So that it is deuterium, and tritium is 1, 3. All of you know. Someone doesn't know, don't worry. You will learn those later. So what are the isotopes of hydrogen? You have to write the names. Protium. The first one is protium. Second one is deuterium. Third one is tritium. Third one is do all the atoms have all 3 subatomic particles? Do all the atoms, just asking, do all the atoms have all 3 subatomic particles? What doesn't have? What doesn't have? There's one atom which doesn't have neutron. What is it? Hydrogen. Specifically protium doesn't have neutron. You can do the calculation. See, if the number of protons is 1, the sum of protons and neutrons is 1, that means the number of neutrons are just right. And there was a text saying that some students didn't understand the idea of not writing the atomic number. What I said was, when you are writing these symbolic representations, you can either write carbon 612, carbon 613, or else just carbon 12 and carbon 13. That's what I meant. Why? Because the 6 part is obvious. Once you write carbon, you know it is, right? Similarly, once you write 6, you know it is carbon thing, but you can't write something like this and expect you to know what the carbon thing. No, we know that, but logically correct. Logically, that's true. Always you can either use this notation or this notation, both are the same. Right. Then back to the, okay, if everything is fine, I want you to do, not now, as homework, do page 5 and page 6. Right, you can do page 5, page 6, and there's few sentences on page 7. Do those as homework. Not you, it won't take long, it will take maximum 10 minutes. We won't give a lot of homework, and that's a promise. We won't give a lot of homework. Most of the work will be done in the class. Can guarantee that. Just do those, 10 minutes will do. At home, කරගෙන එන්න. Right. බලන්න. Make sure online students see everything. Okay. Clear? Done? Understood? Yep. Right. Right. Then Shall we look into the previous question regarding these molecule ideas and all, since there were some interesting questions? Are you tired? Yes. Are you? I'm just asking. I'm not going to do anything about it. I'm asking. Huh? Yes. What is the time? How many classes did you attend? As of now, it's 4:23. When did we have the interval last week? 5? 5, ne? 4:30. ආවෙක් නෙමෙයි මම. 5. We'll have an interval at 5. මහන්සිද? Are you tired? How many classes did you attend as of now for A levels? I mean, not types of classes. How many times did you attend to a class after O levels? Is it a 2-digit number already? Huh? No. 5 classes. So 2 chemistry classes or maybe 1 chemistry class. Then around 2 classes for the other subjects as well. Who are doing bio? Okay. Good luck. Why are you doing bio? Yeah, you answered. Is it, what is more difficult? So bio. What is more difficult? Bio. Math students say it's more difficult. Is it maths or bio? Bio. Any math student who thinks maths is more difficult than bio? Maths more difficult. Any bio student who thinks maths is more difficult? Bio students think. Okay, this is my opinion. Now, when I'm giving opinions, anything except for chemistry, you can ignore. That is the rule here. I don't want you to idol worship me. You know what that means. Most of the students do that for tuition masters. I don't want that. I don't believe. Right. So I don't want that. Hari? You can ignore whatever the things say logically, and you can even argue after the class. Don't argue with me. Something which is not chemistry here. Something chemistry you can, that's fine. Hari? Perfectly fine. My opinion regarding, so this is something not chemistry, right? You can ignore if you want. That time I don't have. Oh, my opinion regarding maths and bio is at least 4 times difficult than maths. My opinion, I can be wrong. I didn't do bio, so I don't know. This is my opinion. I can be wrong. Sorry, that's my opinion. That doesn't mean it can. That doesn't mean now you should go and change to maths. That's not right. This is what I'm thinking. That's because of bio. So if you are doing bio, the margin of error is little bit smaller than maths. Try to some more effort. There are 2 reasons for that. One reason is now if you are doing maths and bio, the difference is between only one subject, right? One subject, then maths, if you understand the logic, that's it. I mean, it's not easy as it sounds, but that's it. But for bio, you will have to continuously keep studying. So that's one reason I see it difficult, right? And the other reason is the amount of students who get qualified for uni. Now that's a fact. You can agree or disagree, you might like it or not, but it's a fact. Now, how many students get selected for the University of Morato in Colombo? Now, we'll talk about Colombo. All of you will be writing exams in Colombo. Then, how many students go to University of Morato per year in Colombo for engineering? 300. No, that you are not. Colombo is not that smart. Do you know what that means? If Colombo is smart, you will get more seats. You don't know how that works. We'll talk about that. There's the merit list and all. You might not know how it happens. And then there's the district quota. It's a whole process. We'll learn about those later. We'll learn how the Z score is calculated. You should know all about those, not only the subjects. Anyway, regarding back to topic, what did I ask? Morato engineering. How many students did selected? Normally, it's around 220. Somewhere around 200 to 230 from the entire Colombo district maths will get selected. The University of Moratuwa engineering faculty. From other districts, there will also come. So let's say, to be fair, I did A levels in 2020. That year it was the highest for the entire history. I don't know, maybe it's a little bit higher now because facilities have increased. Let's say 230. This will one day go to 300. What about bio? How many students who do bio get selected to Colombo medicine? Any ideas? 5. Now that's a fact. Huh? That's a fact. That's not my opinion. Fact. Boat to gena you might have heard of boats. I don't know the English term for that, boat to gila. So if you do not get selected to a certain university, there will be a second round, because some students who do get selected might not do the degree. They might go abroad. Many reasons they might select a different degree. So normally in our batch, only 55 students got selected, 55 or 57. But the district rank 70th also got an opportunity. I know the 70th or the 71st. So I know that's the last seat. After all of that, this goes to about 70, but this is the legal number. The first attempt number. Okay. So you understand. That doesn't mean all of you should attend or try to attend to University of Moratuwa or should attend to this or this. You can have other options. There are other degrees. I mean, you can do what you want. It's true. But when we are comparing something, we can take this as an example to understand. That doesn't mean maths is very easy. So if this is like maybe 1%, like 0.5% out of the 0.5 or 0.3% of the students who are writing A levels in Colombo, I don't know, maybe some rough percent, this is 1%, okay. So it's again very, very low for math students also, but comparing these numbers, it's a little bit difficult. So this is like Jeff Bezos, this is like Elon Musk. Both are rich. There's also a huge gap. That doesn't mean it is easy. Right? So understand that, just wanted you to know this. So bio students, make sure you take bio seriously. A little bit more serious than the other subjects. Again, remembering that is my opinion, you can ignore that. I'm totally okay with it. Right? But that doesn't mean bio students, if they change their stream to maths, they will perform better. That's not what I meant, right? You should select the best stream for you. But understand, if you are doing bio, there's the margin of error is a little bit less. And I have seen many students in my career who were unable to balance bio with the other two subjects, and they didn't do well for the other two subjects as well. Right? They try to balance bio, then they put all the effort there, and then they do not do the other two subjects. So I have seen results like this. Column is bio. Right? No, I'm serious. It's like that. So no need to be afraid, but you should know the reality. I think knowing the truth is what matters, right? You should know. I want to tell, right? That's why I think obviously the benefits are higher for doctors than engineers. Want to talk about those, I might get cancelled, but the truth. An engineer, as an engineering undergraduate, I know the benefits are higher for doctors. Okay. Now back to topic regarding the molecule thing. The full story. I just wanted to a brief idea and go to the next question, but since you asked some important questions, this is the full story. In unit 2, now no need to remember everything. Now this part you can just listen and clear your doubts, that's it. In unit 2, we will be separating the chemical bonds into two parts, one primary bonds, two secondary bonds. We'll learn the differences later. Under primary bonds, we have three types. Covalent bonds. Have you heard of covalent bonds? Okay. Ionic bonds, and then you have metallic bonds. We'll ignore that as well. Mainly, we will be working with the covalent part and the ionic part. Right? Now, everything I taught you actually working if the bond is covalent. That's number one. So I'll go from the beginning. If you want to know everything, you can forget what we did under molecule and the compound part, and this is the exact idea. So regarding covalent bonds, if the chemical bond is a covalent bond, it can either be a molecule or a compound. It can either be a molecule or a compound. Both options are available, right? Now, no need to remember. Some had issues. Others can ignore this. It's fine. If the bond is covalent, it can either be considered as a molecule or compound. Now, to be considered as a compound, what is the requirement? The atoms should be different. The atoms should be different. So, regarding covalent bonds, we can draw this. So, here these are the compounds. The atoms are different. These are molecules. But if it is ionic, if the bond is ionic, it will always be considered as a compound. There are reasons, you will learn those. That is different. That's why examples like sodium chloride is a little confusing under the previous thing I taught. So, sodium chloride, we don't call sodium chloride a molecule. It is a compound. So, if you move to the ionic section, actually, there are things which are compounds, which are not molecules. Shall I repeat again? Types of bonds mainly, you have metallic, we'll talk later. Covalent, for covalent bonds, you have molecules, all are molecules. If you have different atoms, compounds. Then on the other side, all the ionic bonds are compounds. Now that's just a way to remember, but if you ask why, why are all the ionic bonds compounds, I think can't explain it now. There are reasons for that. That is the explanation for the moment. All of these will be learned in unit 70 පාඩමේදී we will be learning about this. Right? Now, there were a few more questions asked regarding this. One, what are heteroatomic molecules? What are heteroatomic molecules? What is the opposite of hetero? Homo. Right? The opposite of hetero is homo. So you know the meaning, right? What is homo? Same sex. Same type. Okay. Hetero, different type. Right. Then heteroatomic molecules, the name, I think. Heteroatomic, the molecule contains different atoms. So for an example, this is a heteroatomic molecule. Can it be? Now here what I am saying is, now take this clearly. What I am saying is, all of the covalent bonds fall to the category of molecules. So can we call this a heteroatomic molecule? Yes. Why? Atoms are different and of course it is a molecule. Why is it a molecule? Because it is covalent. Now if someone is stuck with all of these ideas, what is covalent, I can't remember, I think can't tell for the moment. Later, you'll understand. Anyway, back to topic. Carbon dioxide is a covalent bond. All the covalent bonds form molecules and you can see the atoms are different, therefore heteroatomic molecule. Then similarly we learned that if a molecule which is a covalent bond has but different atoms, that can be known as a compound. So can we call this a compound? Yes. So both are the same. You can call this a compound as well. That is the explanation for that question. So why is carbon dioxide a compound? Because it has a covalent bond and it has different atoms. Then why is carbon dioxide a heteroatomic molecule? Because it has covalent bonds and it has different atoms. Same reasons but somehow ending up with different terms. That is a coincidence. You can consider that as a coincidence. That's number one. Then number two, is this a molecule or compound? This a molecule or compound? HD, hydrogen atom. Now of course H2, molecule or compound? Molecule. Now once you learn a little bit more, things can get a little bit, it can be a little bit confusing at first because now you know a little bit of things. That happens. When you know nothing, it is easier for you. When you start to know things, things start to be a little bit confusing. Fine. H2 is a molecule. Why? Covalent, but same atoms. Not different. So P on this part, the atoms should be different. Ne? Atoms should be different. It is not. What about HD? Does it belong here? Can we consider the atoms to be different, or are both the atoms same? Are the atoms same, or aren't those same? Not ne, H and D ne. Yeah, when we say that the atoms should be different, we mean chemically, not physically. So the chemical property of atomic number should be, when we say two different atoms, it should be hydrogen and some other atom. It can't be an isotope of hydrogen. So again, this is considered as a molecule, right? So if you have anything, if you want, you can write anywhere, up to you. Explanation, we will further learn these later. I am not going to put a note here for this one. If anyone wants to clear doubts, you can ask after the interval, or you can send a chat, or else you can write anything if you want. Then we'll move on to today's work. Other වැඩවලට යමු. Any questions you can ask, right? Anything if you have. What is the equation to calculate Z score? We'll talk that later. The equation is something like this. You won't understand. This is the equation. Happy? We'll learn those. Sorry? We'll discuss how that works. Online students are not happy. Sorry. Okay. That is the equation. So that sigma is, you know, you call this sigma. What is this? Then what is that? That is also sigma. I don't know. Maybe one is capital. I don't know. Both are sigma. This is a term called standard deviation. You will later learn those, so no need to. Now again, Hurry, later we'll discuss those. Hurry, anything if you want, you can write. Hurry. What are the other exams except for maths, physics, chemistry? Why you want more? What do you mean? You mean other streams? So instead of chemistry, you can do ICT. And instead of, and regarding that, some students ask whether it's better to do ICT or chemistry. Now I'm not going to say chemistry because I am teaching. I'll explain the actual situation after the interval. Right? And instead of physics, you can do agri. I can feel that has happened to me as well. The above, I attended the chemistry class which had, there were around 1,000 students and the same thing happened. Very. What are the job opportunities when we select math stream? Oh. Basically, you can do anything. I mean, most of the streams will be open when you do maths. That doesn't mean by doing maths you will get a job, right? You have to get a good result. Otherwise, you can't. Normally, of course, engineer, you know, right? Anything else except for a doctor can be by doing maths. You can't be a doctor. Bio is 4 times hard. Can't. Other than that, you can. Right? But another issue with bio is the streams are limited. The opportunities are limited, not the number. The number of different paths are limited compared to maths. How it is. Normally, you can ask from a student who did bio. In Sri Lanka, if you don't go to a medical faculty, the amount of options you have is limited. You don't have a lot of options. But in maths, it's different. Maths, you can go to the engineering faculty, and then I think I got to know that even for a Z score around 0.9, you will get selected to physical science 0.9 is which is relatively a very low Z score. Normally to attend engineering faculty Moratuva, you need a Z score around 2.05 something. To attend Colombo Medical Faculty, you need something around 2.4. The point again, right? But then again, for maths, I think the number of options are a little bit higher. But of course, do what you like. And if you know that you like bio and you want to do bio, even though the competition and the limited opportunities are there, do it properly. Because opportunities are better relatively. If you are doing maths, still, I mean, the number of seats might be a little bit higher, but that is. Harini, those were the questions asked. Hari. What did I ask you to do? The last thing we write anything out. If you want, you can write. Else we have about 20 minutes before the interval. We'll start the one work. Meantime, quickly go through the note, last week's note if you have. If you weren't there, how many pages did we write? One. Roughly 1.5 pages. 1.5 pages. Make sure you complete it before next week. Hurry. Okay. Right. Pay attention. How to choose between maths and bio. Point flip. HD means H2. No, HD. D is deuterium. You have to do general English. Yes. Know that, right? For A levels, you have 6 subjects. Do you know that? You have the 3 main subjects. Then you have general English. Then you have GIT. That's it. General IT. And then you have general knowledge, GK. And your English result and general knowledge result will be printed on your result sheet. For English, you will get a grade. General knowledge, you will get a. There are people who get 3 A's, but the general knowledge score is low. Then it's a little bit of a. I mean, your result is good, but common sense, nah, okay. Nerd, okay. So people do actually care about the general knowledge score. No need to think of that. Normally, we study general knowledge after finishing the main 3 subjects. So after finishing the chemistry, so the order will be maths or bio, and then physics, and then chemistry. After finishing the chemistry paper, you will have 1 day. No, actually, after finishing the chemistry paper, on the next day, you will be having general knowledge. During that night, you will study in general knowledge and writing. No, that's whatever. Okay, because we don't have time to focus. So it will have it will have questions like was the leader of Iran or Israel who got killed recently, and then you should know MCQs, and then they have questions that you got in grade 5 scholarship. Or they give the dice, and then they ask what is the normally, and then there are 3 friends. One says lies, and then they give the statements, and then they ask who lies. Normal IQ questions. It actually checks whether you know, whether you have common sense. Don't think you will get a low mark. You need to pass general knowledge to go to university. 1 year, I think this is correct. The arts island first failed the general knowledge. Then you don't have main subjects. You have to just write general knowledge the next time while you attend to university. What happens now? You have to get 35, I think, to pass general knowledge. Okay, back to topic. Now, where were we? Okay. We'll discuss general knowledge later. Now listen. Now we have about 15 minutes before the interval. Now the main content. Normally, most of the classes, most of the time we will be spending doing the main content. But for the first few days, we are revising O levels and all. The main content of ours will be less. Anyway, now at the moment, we have discovered the atom. Scientists have discovered the atom, and now we are in the journey of discovering subatomic particles. Right? We are in the journey of discovering subatomic particles. First, we are going to learn what was discovered, how the electron was discovered. So, shall we write a small subtopic first? Discovering the electron. Discovering the electron. Discovering the electron. Then it මේකට පේන එකමද ඔන්ලයින් එකටත් පේන්නේ same නේද right. Right, listen. Okay, now listen. Covering the electron. First thing is you need to understand, did the scientists know that they are going to discover the electron for discovering it? No. When we are discovering something, it's accidental. All of the discoveries are accidents. Very few are, they had clues and they went searching for it. Scientists had ideas that the atom might be able to subdivide, or that the atom isn't indivisible, but they had no proof. So mainly there were three sets of ideas. Few believed. Now the word believed, it wasn't proved, no conclusion, no facts, no evidences, just believed. One, the atom is plain, like the golf ball, nothing else. Right? The atom is plain, like the golf ball, nothing else. And some believed that one option, nothing else. Some believe that the atom contains particles which are neutral. Now, by the time John Dalton had an idea that the atom is neutral, because if atoms, if the entire universe is made out of atoms, if those are not electrically charged, then the atom is neutral. They knew the atom should be neutral. Then there were three options. One, nothing inside. So we have found everything, all done. Two, you have subatomic particles which are also neutral. These are also neutral. The atom is neutral. The subatomic particles are neutral. Therefore, the atom is neutral. The third option is you have particles which have negatively charged subatomic particles and positively charged ones, and the charges are cancelling out. Those were the three ideas. Scientists had some thought that the subatomic particles, but no. Then, now we are going to learn a whole story. Up to a certain point, you will have no clue why are we talking about this. What is the relationship between finding electrons? Why? Because at first, this experiment wasn't done to find the electron. Electron හොයාගන්න කරපු experiment එකක් නෙමෙයි. It was a different experiment. As a result of that, accidentally they discovered the electron. That is what happened. In the 18 and 1900s, something scientists had ideas. Around in the 1800s actually, a scientist named William Crookes, wanted to see whether electricity can be conducted through air. He wanted to see, we call it the electrical discharge. They were conducting experiments on electrical discharge. So basically, can we conduct electricity through air? අපිට gases හරහා electricity යවන්න පුළුවන්ද? That was the question. For that, he used a thing called the Crookes tube. Now, if you Google the Crookes tube, there will be various shapes, but I'll use a basic shape like this. Like a glass tube. And it is not mandatory to be horizontal. Some Crookes are vertical. Doesn't matter. This glass tube contained two metal rods. Like this, two metal rods, which were connected to a voltage source. like this. A voltage. This is the experiment Crookes was doing, which later you will learn accidentally discovered the electron. And then there was a small opening here. We call it a vacuum pump. Learn in a minute why. There was a vacuum. So what happened was William Crookes inserted a gas, any gas, random gas was inserted inside, and then he gave a voltage and then observed what happens. Nothing happened. Nothing happened. We were doing the experiment, that would be neither. Nothing happens and we quit. But then Crookes wanted to see what happens if the air inside this reduced. He started to evacuate the air inside this. Which then what happens once we evacuate, what happens to the air pressure? Will it drop or increase? It will drop, right? Api megen gas when we remove air. So he started to remove the air slowly by slowly. And then at around 100 mercury millimeters. 100 mercury millimeters. What's our atmospheric pressure? What's our pressure? 760, eh? 760 mercury millimeters. Know that? No. Don't know. Okay, maybe in all levels it's 760 mercury millimeters. Our atmospheric pressure is 1 atm is equal to this roughly. Anyway, so once the pressure was reduced, so this is a relatively low pressure, right? A relatively low pressure. Around 100 mercury millimeters, he saw all we call those streamers. Some zigzag shaped rays. So we call it streamers. I think it's not a ray. I'll share some videos with you so you can observe those. Not the effective way to just draw it on a board. Very effective when you see a video, but for the moment, he observed some streamers. Very irregular patterns, close to violet color. Some part of close to violet color. Some zigzag patterns were observed. And then he dropped the pressure to around 10, about 10 to roughly 10 mercury millimeters. Thing around this. Some say this, the first streamers were around 100 and the intensity was higher when it was 10. 10 with it till the same streamers. 2 mercury millimeters once the number was reduced to a very low number, these streamers were born and now they could observe a very smooth line like this. A very smooth line, a beam, very smooth beam of rays, which was again violet color around this pressure. The pressure was further reduced to around this value, and then the entire beam was gone. Everything vanished. Like a science, nothing. Right? So I want to further elaborate. It didn't happen at once. So once the pressure was reduced to this level, we call that a dark space. A dark space appeared and it started to absorb the entire area. Started small and then it grew and then the entire area and the entire region was dark. What happened? At around 100 mercury millimeters, small spikes or streamers of violet color appeared. Now, what are we doing? Simply, you have a glass tube, 2 metal rods, voltage source is given, and then so around streamers at 100 mercury millimeters. Around 10 mercury millimeters, the intensity increased. Around 2 mercury millimeters, it became a very smooth ray, which was smoothly flowing, again violet color. At around 2 mercury millimeters, at around 2 mercury millimeters, sorry, at around this, what happened? A dark space started to grow and seconds it was dark, entirely dark. And then the walls for this end started to glow with a green color. So they didn't observe anything in between. You can't observe anything. There were some green color glowings, but mainly this end started to glow with green color. That's what happened. Then William Crookes wanted to see what happened here, why these happened, whether Now, why did he start this experiment? What was the initial goal? Can you remember now? What was the goal? He wanted to see whether electricity can be conducted through gas. Now, he wanted to see whether that happened actually. Because he saw some colors appearing, some strange observations. He was the first. Now, imagine you are doing an experiment and you are seeing something very strange which no one has seen. Then you want to see what happens. He wanted to conduct few experiments to see what happened. From there onwards, they observed why we can't see this, what happened, why is the green color appearing, why there were purple colors, and why did it change with the removal of gases. So many things were covered. That's what we know up to now. So later, at a certain point, they will realize electrons exist. See how that happened, right? That's what you know up to now. So what's the time? 5 almost. We'll put a subtopic under discovery electron. Subtopic. While you are writing, now when I'm saying a story which is completely new to you, it won't be understood or remembered at once. I know. That's why I'm giving the interval. If you are sleepy, it's fine. I know the first unit is not very interesting. No matter how hard I try to convince it, it's a little bit like history. What can I do with it? Did I design the syllabus? Mama design and I can't do anything about it. I have to teach it. And you need to understand it the best way. I can remove some parts and quickly finish it. Then you won't get the complete idea. So if you are sleepy, you can excuse and go to the washroom and wash your face and come. It's perfectly fine. I want all of you to focus. But I want you to focus. Anyway, no need to put a subtopic, just put a star mark and write. William Crookes. Right, William Crookes. In 1879, William Crookes, 1879, William Crookes studied the discharge. Studied the electrical discharge. You want me to write that? Electrical discharge. In 1879, William Crookes studied the electrical discharge. That's what I said, right? Electrical discharge using the Crookes tube. Using the Crookes tube. Crookes. Using the Crookes tube. Using the Crookes. Right. What is electrical discharge? Whether electricity can be conducted through gases. So yeah, it's actually electrical discharge of gases. If you want in brackets, you can write whether under electrical discharge, the gases can conduct electricity. Whether gases can conduct electricity. Brackets. Whether gases can conduct electricity. Brackets. I think. Right. Using the Crookes tube. Two minutes past 5. After the interval, now it's 2 minutes past 5. You have to come at 5:22. 3 minutes, the interval is, it's not 5:25, it's 5:22. The interval starts now. After the interval, just come at 5:22. That's enough. Any questions you can ask, I'll be here. Even online students, you can send text, I'll be answering. If you are new here, get used to the institute. There are canteens on the other side, washrooms, just get used. Okay. Yeah, toggle again interval quickly. Come at 5:22. Sorry, we'll start. හරිද? ඔව් මවද? නෑ. Okay. හරි. තවට එන්න ඕනේ. මේ රමික ඔන්ලයින් එක ඉල චෙක් වේද දෝසා ඕකේ. Start. The interval enough? No. No. So many things to do. අන්න තියනවා, බොන්න තියනවා, දාන්න තියනවා තුනයි. What else? You need more time for that? Hari, okay, back to topic. We now focus. Now interval is over. You ate and drank, right? And the chats you started, stories you started, you can talk later. Hari, do that later. Now focus. ආවෙන තියා ඉන්නවද? යාළුවා ආවෙන තියා ඉන්නවද? හැමෝම ඇවිල්ලාද? හවුද? නෑ කවුරුත් නේ. Right. Then where are we? Okay, regarding the electrical discharge. රමික මේ අරකද වෙන්නේ? නෑ. ඔයගේ chats තිය. අලුතින් එවම Right. Then don't look at the TV. You can't watch TV while learning. I'll look at the TV. You have to look at me on the screen. Right. Now William Crookes was studying about electrical discharge or whether electricity can be conducted using the Crookes tube, and an online student had asked why it is the Crookes tube, because William Crookes found it. It's simple. Obviously, that's why we call it the Crookes tube, right? Right. Come on. Right. Then that's yes name. Anyway, he was studying about electrical discharge, and then he was using the Crookes tube. Now we are going to learn how the Crookes tube experiments were done and how the conclusions were made. What I want you to do is, I want you to draw the Crookes. Make it a clear diagram. Don't draw a very small diagram. Draw it clearly. Just draw this. Draw this. A simple glass tube with two metal plates. You have a vacuum pump, we'll name those later, and then you have voltage source. Just draw the diagram first. There's nothing to do. Don't have a lot of time left. Focus and draw. We have already drawn the tube. Online students, that I am not the one who is responding to the Zoom. Crew members are being rude. Send a WhatsApp text and tell that the crew members are being rude. Sorry, I'll fire them. Sorry. I am not the one who is responding. Right. We have completed drawing. And shall we start naming what is this? The voltage source. Roughly this is about 10 to 100 kilovolts. Kilovolt. 10 to 100 kilovolts. Some experiments say 10 to 20, some say 100. Be fair, we'll write 10 to 100 kilovolts. That is the voltage source. If you want, you can write voltage source as well. And then this part is known as the vacuum pump. Vacuum 1C, right? 1C and 2U. I don't know. Correct? Only one U. Really? Honey. Vacuum pump. Remove the gas, right? So the gas can be removed from here. That's a vacuum pump. Then this is the Crookes tube, or this is actually a glass tube, right? Glass tube. And you can name that. දෙකක් තියෙනවා. දෙකයි U දෙකයි. එකයි U දෙකයි දැක්කනේ. See, I know. Okay, so we'll have a vote. Some say it is online line pain, otherwise they won't vote. You have this. You have this. You have this. How's that vacuum? No, it's not vacuum. To make things better, signal. Yeah, it is 1C and 2. Arine? Anyone who agrees with me? 1C and 2U? See, that's exactly. I know. Man, sorry for writing bad. Don't use the phone. Nee. Passe check karega. Right. Okay, vacuum pump. Now did I write something else, man? Right. Okay, now enough. Back to topic. Sorry. Now what are the ends? This is the positive end, this is the negative end. Then what happens to these two metal rods? What end is positive? This end is positive or negative? Positive or negative? So this is like what in electrochemistry? In electrochemistry, we will mainly learn two concepts: electrolysis and electrochemical cells. Like right? You can't remember, but this is not like electrochemical cell. For the electrochemical cell, you can't have a cell. The setup is itself the cell, right? When you have a cell or a voltage source here, this is like electrolysis. In electrolysis, which end is the cathode? Now you can draw a similar setup like this. You have the, this is the battery, and then you have the electrolyte like this. You have two metal rods. Isn't it? And then you have the positive end, you have the negative end. This end is positive, this end is negative, right? We call these two metal rods what? Cathode and anode. What end is cathode? Why? This end is cathode. Why? What is cathode? What is cathode? What is the meaning of cathode? Why? Where do we call cathode? Anywhere, what happens? Reduction. If reduction happens, what is reduction? Yeah, gaining electrons. If reduction happens anywhere, we can call that the cathode. If oxidation happens, we can call anode, right? Then here what happens is, we can easily remember what is what. Now, if this is the battery, in which direction does current flow? From positive end to negative end. Flows like this. Then in which direction does the electrons flow? Negative end to positive end. Now, those are concepts you know in O levels. The electrons flow like this. This is the direction of electron flow. Then you can easily say, see, electrons are going away from this, which is what? Oxidation. See, electrons are going away. That is oxidation. So this is anode. Very easy to remember. Electrons are gained. So this is reduction. This is cathode. That is how we remember. Otherwise, don't study for electrolysis. Negative end is cathode, positive end is anode. No, we don't do that, right? Similarly here, if this is the positive end and the negative end, current flows in this direction, right? Current flows in this direction. Then electrons flow in the opposite direction. Harida? Electrons flow in the opposite direction. Harida? Electrons flow like this. Then again, you can see from this metal rod, electrons are moving away or electrons are being removed. That is oxidation, right? So this is the anode. The anode. This side, electrons are coming towards it. That means electrons have been accepted. So that is reduction is done in. Name those, just small text saying anode and cathode. So the negative end is cathode while the positive end is anode. If anything doesn't make sense, you can ask now or later. Fine. ඕන එකක් අහන්න. Right? Alright, done. Shall we write? Completed. If you wrote the anode, the cathode, if mark the positive end, negative end, vacuum pump, the voltage source and all. Don't write this. Right? Then we'll continue. Put a star mark and while writing, see whether you can understand. We are writing something which I didn't explain that much. Star mark and write. Pressure inside the tube. Pressure inside the Crookes tube was reduced. Pressure inside the Crookes tube was reduced. And the following observations were observed. And the following observations were observed. The following observations were observed. Pressure inside the vacuum tube was, pressure inside the Crookes tube was reduced. The following observations were observed. We have several observations. Just we'll write and discuss. Normally when the pressure was around 100 to 10 mercury millimeters, what did we observe? Can you remember? Violet color streamers we call. Streamers is like, see when lightning happens, streamers are running zigzag shape things. Those are streamers, very close to that. Sorry. Then write this. So we can put Roman number 1 or first star mark. Pressure is this 10 to 100 mercury millimeters. violet color streamers were observed. Or else you can write violet color zigzag shaped streamers were observed. Violet color zigzag shaped streamers were observed. දාන්න එපා නේ එහෙම ඉන්නේ නැහැ නේද? The first sheet we hope good. Right. Violet color zigzag shaped streamers were observed. First one. Then the second one ලියන්න. Second one. හරිද? So you have to write violet color zigzag shaped streamers were observed. Then the second one. When the pressure was about 2 mercury millimeters. These are very low numbers, right? 2 mercury millimeters. And the pressure was about 2. Missed anything? Mona miss? When the pressure was 2 mercury millimeters, what did we observe? The violet color smooth. The violet color smooth beam of ray. Violet color smooth of ray was observed. Right? A violet color smooth beam of ray was observed. Now, where are we observing? Where are we? Oh, inside, but normally between the cathode and anode, right? If you want, you can mention that. So, all of these observations are made normally between the cathode and anode, right? And the final one, 0.001 mercury millimeters. In some textbooks, say 0.01, it's fine. Write this. No need to worry about these values. Just need to explain the process. .001 mercury millimeters. What happens? What happened? First, a dark space appeared. Very brilliant. First, a dark space appeared and then it grew, and the entire Crookes tube was dark, and then a green color glow was observed on the end of the anode. Sometimes it say even in between some green colors were observed, but that's the main idea. Haridha, can you explain? Once the pressure was very low, dark space appeared. It started to grow from this end to the other end. Sorry, actually from this end to this, from cathode to anode. And then the tube was entirely dark. And then what happened? And then a green color glow was observed on the end of the anode. Hari? Now keep in mind, in your resource book, most of these ideas are not given. That means for A-levels, these won't be questioned. But for a term test, it can, and it's better to have a good understanding about the story. Hari? No need to brutally try to study these. Remember the story, that's enough. Okay? Then here, write with me. A dark space appeared on the side of the cathode. A dark space appeared side of the cathode. Within brackets, write Crookes space. Put down dark space. Crookes dark space. A dark space appeared in the a dark space appeared on the side of the cathode within brackets Crookes dark space. Comma. And the space grew from cathode to anode while writing ink, okay? And the space grew from cathode to anode. And the space grew from cathode to anode, going until the entire tube was dark. Until the entire tube was dark. Until the entire tube was dark. Okay. Another star mark, still this one, but another star mark. Still this one, but another star mark, and write star mark. A green color glow was observed. A green color glow was observed on the end of the anode. Green color glow was observed on the end of the anode. Else you can write anodic side. This side means, right? The green color glow was appeared. Now see whether you can read all those 3 points and visualize what happened. At 100 to 10 mercury millimeters, what sort of thing did appear? And then at around 2 mercury, these values can change slightly because they are very small values. Some guides might say it appeared at 80, some say at 10. No need to about the values, just understand the concept. At around 100, you saw violet color sparks. Around 10 or 2, we'll see a violet color smooth. And then around 0.001 or maybe 0.01, we see a dark space appearing and the dark space growing. And then afterwards, the entire Crookes will be dark. And then you will observe a green color glow here. Sorry. I mean, I tried to give the best idea, but still I am missing some things. Sorry, if you search this deeply, even between some more observations are made. They are too complicated. I mean, not complicated, but then the amount of theory you will learn is too much. Then no need to. There are stages where you will see violet, dark, violet, dark, violet, dark. Likewise, there are so many stages in this. Sorry, we have just written the main ideas. In your resource book, even this much is not there. So having a very rough idea is enough to explain what happened. Right. Then we are going to explain. So now you know what we can see. Right. And then write the next point. Various experiments were done. Various experiments were done to identify what was causing green color glow. Various experiments to identify what was causing the green color glow and the properties of that. And the properties of what was causing the green color glow and the properties of that. Right. Now read what we have written up to now. From starting from discovering electron, take 1 minute, don't talk with anyone, focus and read. First unit is mainly about memorizing, can't help. Read it quickly, Lian Naban. Sorry? Right. Okay. Are you right? Now listen. Now we have observed a green color glow. Now they wanted to know what happened this entire scenario, right? Later I'll explain why all of these observations were made, but for the time being, the green color glow was appearing because a set of rays were emitting like this. But those are invisible to the naked eye. You can't see these rays, but those rays contain a certain particle. Now, any of these weren't understood, but what the scientists found was a certain ray was being emitted, and then those rays were colliding with the glass tube. And normally the glass tubes are made out of, actually not made out of, the glass tube is coated with zinc sulfide. Later you will learn these zinc sulfide. Normally what happens is when a particle or a thing which contains energy goes and collides with a zinc sulfide screen. Have you heard of electrons exciting? Know the word excited? No, not the one you do. Happens to you. Take enemy. Hari, no need to think about. Hari, anyway, there's a process called electrons exciting, right? Or the excitation of electrons, and due to that, the green color is observed. So that part will be learned actually in hydrogen spectrum. It's something similar to this. Now to understand things, I might be going out of topic and explaining new things. If you don't understand that, it's too. Yeah, just forget it. Come on, man. Let's say something like this. Now you have levels. Do you know that every atom has energy levels? No. Have you learned the hydrogen spectrum in O levels? No. You haven't learned anything, neither. So if I take hydrogen, do you know that there are energy levels that electrons contain in energy levels? You know, ne? Where does the electron of hydrogen, normally where does it have, does it position itself? On the which level? First level, second level, third level? Yeah. First level, ne? You know that because the electron configuration of hydrogen, you write it as 1. That's first level now. So the electron is here. If we supply energy to this, it can go upwards. It's like a game. You have levels. To get more kills, you will level up. You don't play games. Sorry. So if I provide energy, this electron can excite. It can upgrade itself. Similarly, what happens? It can downgrade as well. If the energy is over, now it can fall to this level. From here to here, it falls. So if I give energy, it will upgrade. It will downgrade, and then what should happen to that energy? I give energy, it goes up. It falls down means what should happen to that energy? It should be released. That energy should be released. How does energy travel? In the form of energy. Forever energy travels. Now here the light has energy, right? This light has energy. How does it travel? In the form of what? Heat. No. I mean the light. Pain, the visible thing. Waves, yes. What waves? What waves? Electromagnetic waves. It travels in the form of electromagnetic waves. Now all of that will be taught, just explaining this idea. Then electromagnetic waves, does electromagnetic waves have colors? Yes, of course. Otherwise, how can you see the color here? Yes, of course. Some electromagnetic waves do have. Does all electromagnetic waves have colors? No. How do you know that? Of course, you learn the electromagnetic spectrum, right, in O levels. You have the visible range, then everything else is not visible. Ne? Those don't have colors. Hurry. Now, when the electrons are falling, electromagnetic waves might release energy in the form of electromagnetic waves. That electromagnetic wave was green color. That's how you see the green color. So if someone wants to understand, no need to understand, but if you want to understand, that's what happens. So what happens is when these rays are emitting, it goes and collides with the screen. that screen is being coated with zinc sulfide. When these particles go and collide, an electron excitation happens. Due to that, the color is shown. But for the moment, you can just remember when these rays go and collide here, green color was shown. And also, let's say now try to answer this question. Who observed a small green color here and here as well? Why? Now, mainly most of the green color will be observed here, true. But you observe a small green color here and here and here. Why? Same reason, but why? Why here? Sorry? No? Other answers? So the point is, now here you saw a green color because these rays collided with the substance here, and the substance had electrons or somehow, and those electrons excited, but somehow a collision happened. Now you might not understand the whole excitation, but for the moment, since whatever the particles that were emitted collided, happuna, then green color was shown. Now I'm asking, why can we see green color here? Can collisions happen between the cathode and anode? Then with what is this ray going to collide? Electrons collide with each other. Okay, that's fine, but other than that, gas particles, can we have gas particles in between? Yes, the pressure might be very low, but it contains gas particles. So sometimes these particles which are coming from this end, which came from this end, might collide here and there, and some green color glows can be observed here and here as well. That's the idea. Now these concepts are new, Hari. If you are feeling a little bit uncomfortable, that's not difficult, it's new. Once you understand these are very easy, right? Even people who fail A levels understand these. It's not a expensive thing, but right. Then how to write it? Put a Q and write. Put a Q and write. Q is for question. Put a Q and write. Explain whether explain why, not whether. Explain why a green color was observed. Explain why a green color was observed. And where else it can be observed. Then why a green color or a green color glow was observed, and where else it can be observed, right? So how should you write your answer? Now listen before writing the answer, right? Now, so this is not a question, it's in the theory note, but we are expressing it as a question answer form, right? What is the answer? How should you answer? First thing should be, you should say, don't write. The first thing, when you are answering, always try to write in point forms. It's very important. Try to develop that skill. Right? Normally, when you write long paragraphs, teachers who are marking papers know you don't know anything. Like you do for history. You write a lot of things like you saw, but you have no idea. You just write. So that's not done. We can't do that here, right? Now here the idea is this. The first thing you should write is, first thing you should write is that the rays that are emitted are invisible. That's number one. So nothing can be seen. Or the rays cannot be seen. What we see is when the rays collide with the coating or the zinc sulfide, you can mention that term, zinc sulfide coating of the glass tube. How to write now? No need to write those electron excitations and all. Yeah, just write. The first one should be that rays are invisible, you can't see. The first one I'll write invisible. First one, the rays are invisible. The second one you should mention, the green color glow is observed mainly when the rays collide with the zinc sulfide coating of the glass tube. No need to explain why, it's too much for you at the moment. And the third one, right, where else the collisions can happen? The collisions can happen between rays with gas particles in between the anode and cathode. So green colors can be spotted here and there as well within the cathode and anode. So the answer is little bit long. Try to write and then I'll give the answer. First try. Other places are between cathode and anode. Pi කියලා ලියන්න. Yeah, no, then cathode. What happened on surface? We'll talk about that temperature issue with Crookes later. Sorry. Anything else? Others you can write answers. I'm just when it was 2 mercury millimeters, only one beam. And normally a smooth beam, yeah. The dark space between anode and cathode, yes, yes. Between anode and cathode, normally other places are anyway dark. Why does induction? Right, I'll explain that. Try to write the answer. Online students, some of your questions are actually a little bit complicated to answer to the entire class. So if we don't answer it, that means either your question is or else it was too good for the moment. So just send a WhatsApp text and I'll personally reply to those tonight. Hari? That's the only way we can solve it. මෙතනින් you පස්සේ ප්‍රශ්න අහන්න මට online එකේ ළමයි අහනවා පස්සේ සමහර ඒවා ටිකක් too much මෙතන explain කරොත්. Try to write the answer. කියන්න බලන්න. Is it okay if I read some of your answers to the class? නැද්ද? I'm just asking again මනුස්සකමට I'll do what I want. I don't want. ඔයාලා කියන එක කරන්නේ නැහැ. And one try to write the answer. 3 parts. Okay, so One answer. The rays formed are invisible. The rays collide with the zinc sulfide coating in the glass tube, and green color can be seen because an energy is released. Also, small green spots can be seen between the anode and the cathode due to collisions of rays with gas particles. Yeah, enough. Write something like that. So if your answer is closer to that, that's it. Sorry. Okay. Right. So first remember that cathode. Later we'll name these rays cathode rays. Then it's easier to talk about these. Otherwise, I'm saying that rays gonna. Later we'll name those as cathode rays. Anyway, the cathode rays we are now talking about uh, are invisible. That's very important to remember, right? Time most of you would start to remember that cathode rays are green color or violet color. No, those are invisible. Those do not have a color. Due to the collisions, we see that green color. So mainly three things. Cathode rays are invisible. Second one, cathode rays collide with the zinc sulfide coating. Zinc sulfide, ZNS. Zinc ZNS is capital, right? N is simple. Uh, Zinc sulfide coating of the glass tube or the group, and green color tone, something like that, because we are not explaining the entire idea. And the third one, these rays can collide with gas particles. Therefore, small green color glows can be observed between cathode and anode. These rays can collide with gas particles. Therefore, small green color glows can be observed between cathode and anode. Right? So all good? Any issues? Sure. If you have difficulties, ask after the class also. You can come and say, I write the answer. How can I write it? Can you help me? Fine. Now comes the main idea. Now you have the rays and see the line. Now comes the main part. After the rays were observed, what happens? After the rays were observed, they wanted to find the characteristic features of these rays, right? Then put another star mark and write. Following experiments were done and following conclusions were made. Just following experiments were done and conclusions were made. Are you Pasindu sir or someone else? I told you it's Crookes, not me. Wasn't Nikola Tesla who found the way to transfer electricity atmosphere? Then Ramikadala, he wasn't the first, but he was the one of them to seriously demonstrate it. Are you Pasindu sir or someone else? Hari, so online students, I get the issue right now. Of course, you should understand. It's up to your batch. Hari, can't help it. Hari, up to your batch. I respond to the online chat also. But once the count increases, I think it's impossible. So we have 2 people assigned to answer your chats. If the answers are not satisfying, you can do 2 things. One, ask the answer again from me. 2, tell that the answers are not satisfying, so we can fire them. Hari, right. Then, the following experiments and observations were made. Conclusions were made. Following experiments and conclusions were made regarding these rays. Rays means R-A-Y-S. Rays. Okay. Right. 6. Now. We have one more one. education is the only place where you pay and you want to leave quickly. I mean, you want half of the benefit. Ne? Normally, if you go to a shop and you give 100 rupees and if they give a 50 rupee chocolate, will you be happy? Ne? But if we finish the class 1 hour early, you are happy. Ne? Why is that? What's the difference? Okay. Anyway, the first, okay, now listen. Now there were several experiments done by William Crookes and later some experiments were done by J.J. Thomson. We'll introduce J.J. Thomson next week. And some conclusions were made. Right? Now you have the Crookes tube. Now in some of the videos we share, sometimes you might see these invisible cathode rays. Then don't think you have superpowers. There are ways of making those visible. I mean, when the pressure is extremely low, you can see sometimes, and there are some conditions we can apply so that the cathode rays are visible. I'll use the word cathode rays because it's easier to talk about it. You will get to know why we call it the cathode ray. Sorry. Now I have this. Since we drew the diagram in a way that this end is cathode, we'll maintain that. If you want, you can change directions. Sometimes it might be easier, up to you. The first experiment that they did was, now again, you need to understand, multiple experiments were done. Around maybe 10-20 experiments were done. But some were only some of those were successful. Not learning about the others. Don't think they just did one experiment and it was successful and they conclude. That's not how it happens. We are only learning the main ones. William Crookes kept a Maltese cross. What does that mean? The shape. You have seen a cross, right? Cross, you have seen a cross. Maltese cross is something like this. It's like a flower. Podi lassana aesthetic. Aesthetic cross. Confusing. That's not aesthetic. We call that ugly. I don't know how to draw this. It's somehow this shape in all 4 directions. It's so this shape in all 4 directions. Later, right? I don't know. This is the shape. Google and it's nice, not like this. Sorry. I'm very good at English literature. That sums up. First try was better, I think. Anyway, this is a Maltese cross. So it's a cross, but body aesthetic cross. This, but this as a Maltese cross. You understand it, right? Assume if you can't understand, write Maltese cross and Google can't do anything better than that, right? Anyway, the Maltese cross was kept between anode and cathode. Maltese cross, right? A Maltese cross was kept between the cathode and anode, and then a shadow or a sharp-edged shadow was observed on this end. The Maltese, I'll send the video and you will see a very clear shadow of this was observed here. A very clear shadow was observed here, or sometimes instead of using an anode, they used an anode which had this shape. Both are same. In some experiments, you can do the same experiment by keeping a Maltese cross here, or else you can do the same thing by just making the anode this shape. Doesn't matter. No need to even have this shape. This is enough, but just for fun, we give a shape like this, so that we can prove that it is actually caused because of this. So we normally have irregular shapes like this. Anyway, a shadow, a sharp-edged shadow, we call it a sharp-edged shadow, was observed on the anodic side. What does that mean? What does that mean about the direction of the rays? Is it flowing from here to here, or is it going from here to here? If you observe the shadow here, when you kept an object here, does that mean the light or whatever the stream is flowing from here to here? Or is it going from here to here? Yeah, it is going from here to here, right? So it is flowing from the cathode to the anode. So once you keep the object here, this is the Maltese cross, right? Assume that is the Maltese cross. And the shadow was observed here. That means the source is going from this direction, and when it hits here, a shadow is shown here, right? That was the first experiment. Okay. Then we'll write. So this is how we write. There are three parts. One, experiment. Two, observe the number one, and then under that, experiment. Put one under that experiment. Sorry. A Maltese cross slash. No, just write this. No need slash. Yeah. Maltese cross was kept between the anode and cathode. Maltese cross was kept between anode and cathode. Maltese. This. If you want, you can draw this, but I mean, you also Google. I think you can't do better than this. If you want, you can draw this. This is a Maltese cross. If we see green color because electrons collide with zinc sulfide, why don't we see it on the cathodic side? Because now you learned, because the rays are going from this end. It will, the collisions will happen on this. So the experiment was this was kept between anode and cathode. Within brackets, right? Still the experiment within brackets, right? What is the other way? How can we do it? There's another way. You can have a Maltese cross-shaped anode. Doesn't matter, hurry. This can be done by keeping a Maltese cross-shaped anode as well. This can be done by keeping a Maltese cross-shaped anode as well, right? This can be done by a Maltese-shaped anode as well, right? You got it? Okay. That is the experiment. Then what is the observation? Two things you have to mention about the observation. Monada. A sharp-edged shadow was observed on the anodic side of the anode. A sharp-edged shadow was observed. Sharp-edged shadow was observed on the side of the anode. The side of the anode. The sharp-edged shadow was observed on the side of the anode. So under one experiment we wrote, then we wrote the observation, and then we are going to write the conclusion. Right? What is the conclusion? What? Yeah, how to write it? Rays travel from cathode to anode. Rays travel from cathode to anode. That is the conclusion. Rays travel from cathode to anode. Rays travel from cathode to. Sorry? Done? Right. And then there's one more conclusion they arrived at. If you are getting a sharp edged shadow, that means you can think about it. I'm not going to explain that. You can think about it. Later you will learn these concepts in physics. But if you are getting a sharp edged shadow, that means the rays are traveling in straight lines. If the rays were traveling like this, and the rays were coming from every direction, then the shadow won't be sharp edged. The edges would be blurry. Sorry. Maybe you understand it, maybe not, it's fine. For the moment, right, the next is, we got the same conclusion is, sorry, same experiment, the next conclusion is, next conclusion is, rays travel in straight lines. Rays travel in right. Last week was a game. If someone wants to break fast, online students think you can watch the recording later. Then you can happens. Idea. Okay. Someone has issues like that, just inform me before the class. We can help you. But what is the next conclusion? The next conclusion is rays travel in straight lines. Conclusion. We have around 5 experiments like this now. We have done one. Now after the class, what are you going to do? Go home, obviously, then sleep. Sorry. Haven't planned. After the class, what do you do? Angila inna kattiya. What do you do after the class? Fun thing. I'm asking, any plans? Anyone who is going to watch a movie after the class? Anyone who is going to study or something? No one. Rotary atusanna නැද්ද? පොරොට atusanniwa matusana. No one. Then what else are you doing? Study. What else are you going to do? One is like 2 or 3 were studying. Around 5 or 6 were watching a movie. Others? Games. Game gana. Okay. Others just tell the answers. I mean, the answers we can stay here, right? When answers you're doing something which you can't tell, don't tell. Don't say, sir, you want to yeah, no. What else? What else do you do? Have you planned actually? So most of you, do you have a plan on what to do? You don't, right? That's the point. That's what I wanted to highlight. Most of you don't know what you're going to do. You just go home and then you just be there. You just exist, right? We call it existing. Just exist. While you will scroll a little bit. You won't relax. You won't entertain yourself. You won't either work. You won't any of that. Right. That's the issue, right? In A levels, you will very quickly realize that you don't have enough time to either work or to enjoy. If you feel that the reason is you not planning things. If you plan things, once you go home, you will realize you have so much time left. If you know exactly you are going to do this, let's say you are going to work, let's say you are supposed to do some MCQs. Now, right now you might not have, but let's say next week or week after, you have some homework to do. Then exactly if you know you have that homework to do after the class, before joining the class, what you are supposed to do is prepare those books and keep those on a table. Now, some might think, no, actually it's better if you... Then you go home, you quickly finish those, and maybe, realistically speaking, you will have time to maybe watch a movie as well. But most of you won't do either of those. You just scroll, watch some TikToks, watch some Instagram. If you know what Instagram is, then you watch. Most of you don't know, I know that. And then you will sleep. Most of you won't even sleep. And you just fall asleep, right? Don't go to the bed and think I am going to sleep. You just be existing on the bed and then you will fall asleep. Isn't that true? So try to plan that. From day one onwards, try to have a small plan. Don't make timetables. Anyone who has a timetable? Does anyone have a timetable? If you have a timetable, I'm not saying it's bad. I'm not saying it's bad. If you have a timetable, it's fine. But for most of you in your life, you have had a timetable which didn't work. You tried to prepare a timetable, you did, you table and then put, and you had so much satisfaction on day 1 and 2, etc. Why doesn't timetables work? Why? Because the modern life is irregular. You can't have a timetable for Monday. You don't know what happens on the next Monday. Lot of things can happen. Even a world war can happen and the next Monday might not exist. So it's very irregular. It's very irregular. So many things can happen. You might have extracurricular, you might have a function, you might have extra class. So your days are very irregular and you have so many things to go on to. You have social media to watch, you have films, you have that, you have this, you have friends to talk, you can do many things. So normally, timetables are not very efficient nowadays. Just plan the next. What I do is that, right? Normally what I do is, before sleeping today, I write down all the work I have to do as a note on a piece of paper, if I have a lot, or else if I have 5, 6, it will be on my phone as a note. Then when I get up on the next morning, I know these are the things I have to do. So my goal is to finish those as soon as possible and watch a movie. But normally I won't finish not the lot entire day. That's because I have a lot to do. But for you, it won't be the case. If you have a list of things and you know exactly what you are supposed to do on that particular day, and then you prepare for that. Now imagine you go home and all the things you are supposed to do are on your table. You have all the books arranged. Then you just sit down and finish those and done. Then you can do whatever you want. Even plan that. If you are watching a movie, plan that. Then you can save a lot of time. Then you will realize you have so much time in life. So much time in life. If you want to take motivation, take from who? Take from Elon Musk. He has a net worth of $800 billion. I know you can't comprehend that, so I'm not going to try. And he has 14 kids. Right? He has 14 kids. So, පොරට ඔය දෙකම manage කරන්න පුළුවන් නම්, and you don't say you can't manage 3 subjects. Right? You can. Need to manage time. Be efficient, that's it. So try to have a small timetable. Wait. Try to have a small timetable. I mean, not a timetable. Try to have a small plan. Every day before you sleep, write down what you have to do. I want 5 minutes. Wait. Now you don't have a plan. You have nothing to do. So wait. Right? You don't have anything to do. Wait for 5 minutes. So make sure to have such a thing. It will be very easy. Otherwise, very quickly, especially when school starts, you will feel that you don't have time. Most of the students complain. We try to work, but we don't have time. We have so many classes, we have school, we have this, we have that. We don't have time. That's because you don't plan and you waste so much time. Just count and see when you go home. Normally, most of you will be at home around 7:38. Most of you will be home at 8. Now it's 6:30. But most of you, if you are starting work, will start at least after 10. From 8 to 10, no one knows what happened. Try to reduce that. Then you will have a lot of time in life. Important. Okay. Before ending the class, the first thing is I gave you some homework. What is it? I asked you to do the O levels to A level tude, right? I gave you some pages. That's one. The tude, complete that. Then number 2, there's one thing you should do every week. What is it? One thing you should do every week. Yeah, Aufbau is in the class. At home, there's one thing you should do every week. Yeah, you should go through the note. The note might not be very long. Things might be very easy to remember, but still you have to go it just for the habit. But still go through it just for the habit. You have to get the habit. Otherwise, you will miss it very quickly. So go through the note. And then the third one is, if any one of you is not on the WhatsApp groups and communities, make sure you send a WhatsApp text today. If possible, now even it's fine. And get added, because videos and now as of up to that moment, I haven't sent any academic stuff. But the videos and all will be sent here. So be on this. All the notices and everything sent to this. Sometimes it might be a sort of annoying thing. I am sending the same message again and again. That's because some of you are not paying attention. And finally, For online students, I'll let you know how the tudes and all will be arranged. So just pay attention to the WhatsApp group. So basically pay attention to the WhatsApp group. Everything will be notified there. For any emergency, send a text here. Yeah, that's it. Then quickly, earlier you want to go, right? 6:31, it's 1 minute late. You don't want to revise what we did today? No. You want to go? Since you put your books in, it's good now. We can revise. Now you are not looking at your note. We'll quickly revise. No need. What did we learn? From the beginning. We started to learn the discovery of electron. And then now we are talking about the Crookes experiments done by Williams. Right? Okay, so the first things you need to be able to explain how the Crookes experiment was done. See whether you can remember how the Crookes worked. And then what happened? So the setup was like this. And then what was the first thing William Crookes did? He reduced the air pressure, right? Then what happened? At around 100 mercury millimeters, we saw violet color streams. At around 100 mercury millimeters, we saw violet color streams. And then around 10 mercury millimeters or 2 mercury millimeters, right? So mercury millimeters, we saw a ray of violet color or a beam of violet color ray. Then at around very low 0.001 mercury millimeters, what did we see? Yeah, a dark space appeared, which is dark space, and then it grew. And then on the anodic side, we observed green color. And then you all wrote answers how that green color was observed and where else that can be. And then we started doing experiments. What was the first experiment they did? They had a Maltese cross. What is the observation? Observation, a sharp-edged shadow on the anodic side, or the side of the anode. What are the conclusions? One, that the rays are traveling from cathode to anode. Two, the rays are traveling in straight line. Sorry. Okay, then that's it. Thank you for joining. We'll meet on next Friday. Okay. Right. Online students, if you want, you can be on the Zoom chat. I can reply to your messages, or else you can leave and send a text here. Your messages weren't replied. Hurry, young parisaming. Amidu. Araka balan potta. Good,